Avogadro's law. Equal volumes of any two gases at the same temperature and pressure contain the same number of molecules. At standard temperature and pressure, 1 mole of any gas contains 22.4 liters of the gas. And so under standard temperature and pressures, we can work stoichiometric problems with these by changing the quantities that we have into moles of the gas. And when we have moles of the gas under these conditions, we can change it into a volume. And the standard temperature and pressure is 0 degrees C and 1 atmospheric pressure. We'll talk more about exactly what pressure means in the following set of slides. Okay, so now we are going to do some problems using Avogadro's law, some stoichiometric problems, and you will find that these are very similar to the stoichiometric problems that we did before. And so let's start with a flow chart here. We'll have grams to moles just like we did in the previous units, and we'll use the molar mass off the periodic table to make that conversion. And then we're going to go from moles of one chemical to moles of the other just like before, and then we're going to use the coefficients off the balanced equation just like before to change from one chemical to the other using that balanced equation. And then instead of going from moles to grams again, we'll go from moles to liters here using 22.4 liters is equal to 1 mole. And that is under standard temperature and pressure conditions. Alright, so in this particular problem we're given 500 grams of pentane, and we're asked to solve for liters of CO2. Liters of CO2. Alright, so we're going to go from grams to moles, then we're going to go from moles to moles, and then finally moles up here to liters. So we'll have 3 steps, and we know that we have to get into a mole amount to change 2 moles of carbon dioxide. So here we'll have we'll have grams of C5H12 for every 1 mole of the same. And to save ourselves some time, I went ahead and calculated the molar mass of C5H12, and that is going to be 72 grams. Alright, so maybe we'll go ahead and do that on this first one. C5 times 12 is equal to 60, right? And then we have H12. 12 times 1 is equal to 12. So that gives us 72 grams per mole for that guy. So now we're at moles right here, and we'll need to go to moles of the different chemical. So we have to go over our mole bridge here. So we'll have moles of pentane on the bottom. Remember, whatever you have on the top has to go on the bottom, so it'll cancel out. Our grams have already canceled out. And then we'll have, for C5H12, we just have 1 mole because there's no coefficient in front of the chemical symbols there. And then to solve for, we're going to go to carbon dioxide, so we have 5 moles of carbon dioxide. And then our final step here, we're going to go from moles to liters. So since we have moles on the top, we'll say every 1 mole of CO2, we've got 22.4 liters of carbon dioxide. So moles of CO2 will cancel, and our final answer will be in moles. I'm sorry, excuse me, liters. I'm getting excited there. Liters of CO2. So if you multiply across the top, 500 times 5 times 22.4, and then divide that by 72, you should get 777.8 liters of CO2. We've got 4 significant figures at our starting place, so we'll get 4 in our answer. Alright, so now your turn. Pause the video, work that problem, and see how you come. Alrighty. Alright, hopefully you've done that. So now we're starting with 500 grams of high quality H2O. So in this problem, we're starting with 500 grams of this guy, of the product, and we're asked how many liters of oxygen are needed for that. So let's do this one. Work it backwards. Why? Because it's so much fun. 500 grams of H2O. Okay, so we're going to have to get to moles. Remember, you always have to get to moles to change chemical species. So I've done that one for us. It's 18 grams per mole for water. And then we'll go over our mole bridge, changing chemical species. We'll have moles of water on the bottom. And here we have 6 moles of water. and then we'll have moles of oxygen on top, because that's what we're solving for. We're eventually going to get to liters there. We've got to go to moles first, have 8 moles. You've got to crawl before you can walk, right? And then finally, our last step here will be moles to liters. For every 1 mole of O2 at standard temperature and pressure, STP, we have 22.4 liters of O2. And if you do that one, you get 829.6 liters of oxygen. Alrighty. Alright. So that concludes recording 1. You may be asking yourself, well, what if I don't have standard temperature pressure? How do I predict the amount of volume that I can produce? Well, we will do that in the following slides and talk more about some other gas laws besides Avogadro's law. And so, fun. I think you'll enjoy these units on gases. Just a neat way of connecting math to concepts.